Shown below is a table with values of cosecant and secant of different angles. So a table is given to you and we are given a question. What are the values of P and Q? 4 options have been given to us. This is a 1 marker. So now let us see how this can be solved. When you look at this particular table, one thing that you should immediately notice is that these two angles add up to 90 degree, which becomes complementary angles. Now, if you want to apply the concept of complementary angles, you have a direct formula which says that sec of 90 minus theta is equal to cosecant theta. So, sec of 90 minus theta is cosecant theta because sec and cosec are complementary to each other. Now, which means that cosecant of 35 degree and sec of 90 minus 35 degree will be the same value. So I can say that P is equal to 1.7 and Q is equal to 1.1. That is when you apply the concept and the formula for complementary angles. Let us suppose you assume that you have no idea about complementary angles or you somehow forget the formulas during the examination. So how do you tackle this sum? Let's have a look at this right angle triangle where an angle A is a 90 degree. If angle B is a theta, angle C can be marked as 90 minus theta. You get it from sum of angles of a triangle. Now, I am going to write the trigonometric ratios for theta. So, cosecant theta is hypotenuse divided by the opposite side. Opposite side is AC for theta. And sec theta is hypotenuse by the adjacent side. Now, if I am writing the trigonometric ratios for 90 minus theta, sec of 90 minus theta, this is 90 minus theta, it is hypotenuse divided by the adjacent side, and cosecant 90 minus theta is BC by AB. Now, what do you notice? Cosecant theta and sec 90 minus theta has the same value of BC by AC, and sec of theta and cosecant 90 minus theta has the same value. So, from here you can see that cosecant theta and sec 90 minus theta has the same value. So, P is equal to 1.7 and Q is equal to 1.1. So, this is one right angle triangle and this is the second one. This angle is a 45 degree and this angle is given to be a 60 degree. Now, other than using Pythagoras theorem for right angle triangles, we can definitely use the trigonometric ratios very comfortably now. So, you can take whichever trigonometric ratio that you want regarding the angle 45. Because I am going to take sine 45 because if I am taking sine 45, I will directly get this hypotenuse. So, let me name the triangle first and then find the measurements of the sides that we are going to get by using the trigonometric ratios. I have named the triangle in this way. You can proceed even without naming the triangle by using the terms base and hypotenuse. So here we need to find RS, which is this side. I have taken sine 45. Sine 45 is opposite side by hypotenuse. So I know the value of sine 45, which is a 1 by root 2. So I am able to find out the value of QR as a 2 root 2 centimeter. And when you solve that, you get 1 mark. So you have found the hypotenuse for this triangle, which becomes a hypotenuse for the second triangle also because this is a 90 degree. Now I need to find RS, which is the adjacent side to angle 60 degree. So I am going to take cos 60. Cos 60 is equal to RS divided by QR, adjacent side by hypotenuse. I know the value of QR, I know the value of cos 60. Solving, I will get RS is root 2. For that, I will be getting 1 mark. So, 1 plus 1 in total will give you the complete 2 mark. If 1 plus sine square theta is equal to 3 sine theta cos theta, show that tan theta is equal to 1 or 1 by 2. It's a 3 marker. So now let us see in which way we can solve this particular sum or if there are multiple ways in which we can do the sum. If you have already attempted this sum or are in the process of attempting it, you will realize that this is not a straightforward sum. Straightforward in the sense that you cannot convert a sec or a cosec into sine and cos and start with LHS and a few manipulations and you get the RHS. This sum requires a different thinking. The reason being because the question is in terms of sine and cos, whereas what we need to prove is in terms of tan. So, in order to prove this particular value of tan theta is equal to 1 or a 1 by 2, we need to extract the tan value from this sine cos equation. How do you get a tan from a sine or a cos? We get a tan from sine or a cos by dividing sine theta by cos theta, right? Now, in this case, I have got a sine square theta, which means that I need to divide sine square theta by cos square theta. So, when I am dividing one term, you know that I have to divide the entire equation across. Here I have divided the entire equation by cos square theta. So in the LHS it is 1 by cos square theta plus sin square theta by cos square theta is equal to RHS. Now 1 by cos square theta is a sec square theta plus tan square theta is equal to 3 tan theta. For writing till there I'll get half a mark. Okay. Now the sec square theta I will convert it into 1 plus tan square theta by applying the identity sec square theta minus tan square theta is equal to 1. So it is 1 plus tan square theta plus tan square theta is 3 tan theta. For applying the identity, you get half mark. Now, combining this you have somehow modified the equation and written it neatly. You get half a mark. Rearranging the equation, you get this. Okay. Now, solving the equation, I have done it using the quadratic formula minus b plus or minus root of b square minus 4ac by 2a. You can either use factorization or factoring the terms and find the value of tan theta as 1 and 1 by 2. The solving of the equation will give you 1 mark. This is how the marks are split for this particular question. Now, is this the only way for doing this particular sum? Let us see. Let us take a situation wherein dividing by cos square theta does not strike you at all. So it is very common that we normally when we do the sums, this kind of manipulations do not happen very frequently. So it is not necessary that you will remember that I need to convert everything into tan square theta. So let me divide by cos square theta. Okay. If that is the case, at least you should attempt the sum. So what do? Here, you can see that you cannot substitute anything, you cannot do anything. But there is a number over here which is 1. See, whenever you have a number like 1 in an equation like this, you should immediately try to substitute it with the identities if it is not matching anything. You can either use the identity sin square theta plus cos square theta is equal to 1, sec square theta minus tan square theta is equal to 1 or the cosecant 1. Fine. In this case, because the equation is in sin and cos, I am going to apply the identity sin square theta plus cos square theta is equal to 1 over here. So here you can see that I have substituted 1 as sin square theta plus cos square theta. The remaining equation remains the same. Adding sin square theta and sin square theta, I get 2 sin square theta minus 3 sin theta cos theta plus cos square theta is equal to 0. Now you have a quadratic equation not in a single variable, but you have multiple variables, which is sin square theta and cos square theta. In real, you can solve it even by using the quadratic formula, but for your understanding, I have used the splitting of the middle term over here. So 2 sin square theta retained as such, minus 3 sin theta cos theta is minus 2 sin theta cos theta minus sin theta cos theta. Now you can see that I can take out common terms from the first two and the last two. So 2 sin theta into sin theta minus cos theta, and from these two terms I have taken out a minus cos theta. Now sin theta minus cos theta is common over here. So you will get the product of two terms is equal to a 0. Either the first term is a 0 or the second term is a 0 or both are zeros. So when the first term is a 0, you will get sin theta is equal to cos theta or tan theta is a 1. In the second case, 2 sin theta minus cos theta is a 0. After doing, you will get tan theta is equal to 1 by 2. So you have got the answer. In the previous sum, dividing by cos square theta in order to get tan square theta was thinking out of the box. Now here you have a similar sum again taken from the CBSE website on their sample papers or previous year's question papers. I don't remember which. Here also we are trying to convert the entire equation in terms of tan theta. Have a look at this particular question. Find an acute angle theta when cos theta minus sin theta divided by cos theta plus sin theta is equal to this value. We are given an equation, we need to find the value of theta. So, when we are dividing the entire equation by cos theta. Now, why are we dividing by cos theta and not by cos square theta? The reason being, the powers over here, they are 1. So, I don't need to divide by cos square theta. In the previous case, I had a sin square theta So I had to divide by cos square theta. Okay. So here when you are dividing, you will get 1 minus tan theta by 1 plus tan theta is equal to this particular value. Now how do you solve it? You don't have to go for rationalizing or anything. Just basic cross multiplying. So let us see what we are getting. Here I have cross multiplied and this is what we are getting. Now you can see that LHS and the RHS contain same terms. So here you have a 1 and 1 get cancelled. Now minus root 3 tan theta and minus root 3 tan theta gets cancelled. So let us segregate the remaining terms, variables on one side and constants on the other side if there are any. I have a root 3 here and I have a minus root 3. So I will get a 2 root 3 and minus tan theta and plus tan theta will give me minus 2 tan theta is equal to 0. Or I can say that tan theta is equal to root 3. Theta value will be 60 degree. So I can say theta is equal to 60 degree. Okay. So now let us see whether we can do this sum without converting it into tan theta. Here you can see how the marks have been distributed. Conversion into tan theta gives you 1 mark and the remaining calculation is 1 mark. Okay. Now let us see the other method. I have just cross multiplied without converting it into tan theta. So once you do that and open the bracket, this is what you are getting. So now let us see whether there are any terms which are same on both the sides. So I can cancel them out. So here you can see cos theta is there. I can cancel. And root 3 sine minus root 3 sine theta and minus root 3 sine theta. Now let us compile all the remaining terms. Root 3 cos theta and minus root 3 cos theta. So I will get 2 root 3 cos theta. This is gone. I have a minus sine theta and I have a plus sine theta will give me 2 sine theta. Okay, 2 and 2 I can cancel. So I will get root 3 cos theta is equal to sine theta, or I can say that root 3 is equal to sine theta by cos theta, which is tan theta. So which angle will give me a root 3 here? It is 60 degree. Prove 1 plus tan square theta is sec square theta. So I have substituted it over here. 1 plus cot square theta is a cosecant square theta. Then I have written sec square theta as 1 by cos square theta and cosecant square theta as 1 by sin square theta. The next sum is a 3 marker and it is based on a diagram. Shown below is a cuboid. The length, breadth and height of the cuboid is given to you. Okay. Now we need to express cos theta in terms of length, breadth and the height. Okay. Now the theta angle is marked over here and there is a second part for the question. So now let us see how we can find out the value of cos theta from this particular diagram. In this particular diagram, though the angle theta is given to you, a triangle is not directly given to you. You have a cuboid and inside that there is an angle theta. So our job is to figure out the triangle from the diagram and how to find out the sides in order to evaluate cos theta. Okay, now you can see that ECH, the angle ECH is given as a theta. Now you know that ECH is a triangle. It is a right angle triangle. So why do I say it is a right angle triangle? This is a cuboid. Your normal textbook or your reference book or your notebook, all of those are cuboids. Even the instrument box or the pencil box that you use, they can, they can be compared to a cuboid. Now, if you compare it with this diagram, this is the vertex C. Now, this is the vertex G and this is the vertex H. Now, this particular line joining C and H. So, if I am drawing a line from C towards H. So, this is my vertex C and this is my vertex H. So, I am drawing a line like this which becomes a diagonal which is mentioned as a CH. Now, this particular diagonal which ends at this corner H is at right angles to this side. What is this side? This side is actually HE. This is H and this is E. So, I can say that there is a 90-degree angle over here, thus making ECH into a right angled triangle. Now that we have gotten a right angled triangle, let us write the value of cos theta. What is cos theta equal to? Cos theta is adjacent side by hypotenuse. Which is a hypotenuse? CE, the side opposite, 90-degree angle is a hypotenuse. So, I can write cos theta is equal to CH divided by CE. Okay. Now, we need to express cos theta in terms of L, B and H. So, let us see how we can do that. CH is the diagonal of the base of the cuboid. The base of the cuboid is a rectangle. The diagonal of the rectangle is given by L square plus B square. Okay. So, I can write CH is equal to L square plus B square under the root. Clear? Now, let us find CE. There are two ways of finding CE. One is directly applying the formula for the diagonal of a cube. Diagonal of a cube is given by L square plus B square plus H square under the root. Suppose let us assume you have forgotten the formula for the diagonal of the cube. How do I figure out the value of CE? So, how do you find CE? You know that the triangle ECH is a right angle triangle. So, you can apply the Pythagoras theorem. You can say CE square is equal to CH square plus EH square. What is CH square equal to? It is L square plus B square plus EH square is H square. So, my CE becomes root of L square plus B square plus H square. Now, for finding out the measure of CH, you will get half mark, and for finding out the length of CE, you get half a mark. Okay, now let us see the following steps which we need to arrive at the value of cos theta and see how the mark is divided. Cos theta is CH by CE, we have already seen that, and this is the ratio. For that, you will get 1 mark for writing down cos theta is equal to adjacent side by hypotenuse and applying the values over here. Now, there is a second part for the sum. If the given figure is a cube, find the value of cos theta. What happens when the given figure is a cube instead of a cuboid? In the case of a cuboid, L, B and H may or may not be equal. In the case of a cube, L is equal to B, B is equal to H. All the three quantities are equal. So, when I am applying it over here, you will get, cos theta is equal to, suppose let us take B and H are both equal to L. So, you will get L square plus L square by 3L square, because this is L square, this is L square and this is L square. So, you will get 2L square by 3L square, or you will get root of 2 by 3. For finding out the value of cos theta in the case of a cube, for this calculation, you will get 1 mark. Okay. A 90 centimeter wide door opens on one side of the room at a maximum angle of 90 degree. Due to shortage of space, a 40 centimeter by 80 centimeter table is kept behind the door along the walls such that it obstructs its path. At what distance from the hinge should the table be kept that the door opens for a maximum angle of 60 degree? Root 2 and root 3 values are given to you and the diagram is also given to you. And surprisingly, this is just a one marker, though the question is pretty lengthy. Now, the main problem in this particular question is the visualization of the actual diagram with the measurements. So, let us see how we can do that. This is a diagram that is given to us, and this is the door and this is the hinge, that is where the door is fixed to the wall or whatever. Now, when you close the door, this is our initial position, correct? So the initial position of the door, this is the wall, the initial position of the door is this when the door is closed. So the length of the door never changes, it is 90 centimeter. If there was no obstruction in the room in the form of a table, I could have opened the door completely. From here, moves like this and goes till here, correct? So the difference between the initial and the final position is a 90 degree. But in this case, there is a table which is kept due to the shortage of space and the size of the table is given by 40 by 80. We need to find where the table should be kept so that the door can be opened to a maximum of 60 degrees. So which is a comfortable width for a person to enter or whatever be the reason. This angle has to be a 60 degree. So immediately you know that this angle should be a 30 degree. The total angle is a 90 degree. If the door has to be opened at least 60 degree, the remaining angle has to be a 30 degree. Now let us see where the table has to be kept. We need to find the distance of the table from the hinge. This is your hinge. Suppose you are keeping the table here, you need to find this particular distance. And the table is kept along the wall. Now there are two ways of keeping the table. Either the 40 centimeter can come over here or the 80 centimeter can come over here. Let us check both the scenario. I am keeping the 40 centimeter along the wall and the 80 centimeter in this way so that there is an obstruction to the door. Now the distance from the hinge to the table is x. We need to find that value. This angle is a 30, so I have a 90 degree triangle over here. I can write tan 30 is opposite side by adjacent side, or 1 by root 3 is 80 by x, or I can say x is equal to 80 into root 3. The value of root 3 is given to you as 1.73, which is 80 into 1.73. Now what has happened? Now what has happened is that 80 into 1.73 is a value more than 90. It basically means the x value is more than 90, which means that the table is somewhere here. The door can open without any obstruction. That was not our intention. Our intention was to keep the table in such a way that the door is obstructed and the angle here is only a 60 degree. So I cannot keep 40 centimeter along the wall. I have to keep the 80 centimeter along the wall. So this is 80 and this is 40. So what will happen to tan 30 now? Tan 30 is 40 by x, or x is equal to 40 into root 3. When you calculate the value, you will get a value somewhere around 69 something. So that is the value of x. Let us find out the exact value. You will get the value as 69.2 centimeter.